All right, folks, if you want to go ahead and grab a seat, we're going to move on to the next talk of the day. Next up, we have Mr. Mike Reeves, and Mike formerly was at a Fortune 5 company, one of the largest companies in the world, one of the largest networks in the world, and he helped to run one of the largest squeal deployments, one of the largest NSM deployments in the entire world. So he's certainly an expert at knowing how to scale these technologies and give visibility to very large networks and very large enterprises. So please join me in welcoming Mr. Mike Reeves.
Thanks, Doug. I'm also known as the guy that's in between you and lunch. So, happens twice in a row. So my name is Mike Reeves. I've been doing this for a while. My main focus has been on IDS and Unix. I work for FireEye, which I was actually working for Manient, and FireEye bought us. Like Doug said, I spent 12 years at a Fortune 5, and I created something called Onion Salt for Security Onion. Just a little bit of background. When I started at security at this place, we had one of the first squeal installs, and then I actually came over to our corporate security team where we started rolling out sensors. When I joined the team, we had, I think, 12 or 14 sensors. When I left, we had 460-something sensors. We had 800 taps. So it's quite a big challenge, so to speak, to cover all of that area. So what I'd like to do is, when I give this talk, is talk about what is NSM, right? A lot of people ask questions like, what is NSM, right? We do IDS or we do IPS, but what's this NSM stuff I keep hearing about? And I like to use the Richard Baitlick definition, which is it's the collection, analysis, and escalation of indications of warning, detect, and respond to intrusion. So another way to put that is it arms the analyst with everything they need to make a quick decision in order to say, is this something I need to escalate? Is this something I need to move forward with? Giving them that information. And why is this information important? Well, we can take the typical IDS versus NSM scenario, right? So, if back in the day, you would look at an alert come in, like like the ISS console or something back then. You would look at an alert come in and say, I see this signature go off, right? So you look at it and you say, well, yeah, this signature is bad. Let's say it's a first stage, somebody exploiting a flash vulnerability. So we see that alert come in and say, okay, this person has a flash vulnerability. So I put in a request to the IT guys and say, hey, this machine 12345 is owned, right? Or it could be owned. Can you take a look at it? So what do? They go over there and they fire up antivirus and they scan and say, oh, it says it's clean. We're good. Close the ticket. Why are you security people making us run around, right? These guys are horrible, right? Because they've got us doing. So you take that same scenario and you apply it to NSM. So that alert comes in. You look at it and say, okay, well, it's the first stage. They owned the Flash client on there. You pull up the transaction log or it's escaping my mind, but you pull the transcript. There it is. You pull the transcript up for it, and you see that it was you saw the first stage, and then the second stage you see it go down, and you see it connect and grab another file from a website, an exe file that probably got executed. Then by looking at that transcript, you can also see, okay, well, what else did this thing connect to? Well, right now you see that it has a C2 connection to the Ukraine and Turkey. You don't know if it's a C2, but if you're a company in America and this person shouldn't really be talking there and they've got open connections to there, that's a good idea that, hey, there's something wrong. So you open that same request with IT support. They go out there, they scan it again, they say, hey, this thing, there's nothing wrong with it, the antivirus says it's cool. Well, the great thing about NSM is you can pull that, so you know what they downloaded, so you can pull that binary out of the PCAP, and now you have it. So you can throw that in Cuckoo, you can throw that in anything. You take it, throw it into Virus Total, and then you find out that, hey, this thing that they said, you're crazy, there's nothing wrong with this. You now know that the antivirus vendor that you use doesn't recognize the virus, but 20 other ones do, right? So that gives you a situation where, you actually, from a security perspective versus IT, you win, right? So But it also helps the other way around. So let's say you could say, we see the first stage, right? And instead of putting in a ticket and going crazy and getting everybody riled up, you saw that it got a 404 when it went to get the second stage. So you know that that machine needs to be patched, but you do know that when it went to grab the evil, so to speak, that it didn't work, right? So that now you've saved yourself time. So, it gives, again, it's arming the analyst with what they need. And I did a blog post about this scenario. It was a real scenario. So what are the challenges of bringing this into the enterprise? So the first thing is always convincing your management that, hey, I need some money. The network teams, hey, I need to put these boxes in front of your routers and switches. Where do I put them? Once they say, okay, that's cool. What do I do when I've got lots of bandwidth? Lawyer people, what do I do with those people? Because they're going to be like, oh, you're sniffing the network. You're doing stuff. Now I got all these devices, these new devices, and I don't want the admins to manage them and then dealing with all that data. So let's get compliance out of the way because it's the most boring. When you deal with global deployment, so the company I worked at had a very huge global presence, obviously with 500-something devices. We had lots of stuff in France and in Germany where they have really strict privacy concerns, right? So you need to check with your work councils or legal departments to make sure that, hey, if I put full PCAP out here, am I going to run into some issues, right? So check with your legal folks, right? You always want to protect the data, right? So a lot of times the targets of your incidents are your administrators, right? So I always use the Windows admin thing where you have patch credentials on your Windows server. Your Windows server is owned from some sort of SQL injection attack. Now they have that person's credentials, right? Or it could be a keylogger situation or whatever. Because once you as an adversary, if you go after those people, it's a lot easier to get one of them and use that credential all the way around. So you don't want them to have access to your systems that have all your indicators on there, right? You don't want the bad guys knowing what you're looking for so that, they'll be able to adjust their TTPs to get around that. Learn BPFs. BPFs are very important. So, this company that I worked at, we had a financial sector, and there was lots of PCI, and we had a medical sector. There was HIPAA, but you weren't allowed to PCAP certain traffic, right? So if it had to do with credit cards or something like that, or it had certain personal information. So we wanted to look at snort, we wanted to see the connection info, but we just didn't want to PCAP it. So in security, there's ways for individual services to put PCAPs in, or BPFs in, or just say NetSniff NG in this case. So what's the best way to convince your manager? Find an old box that you have sitting around that has 8 gigs of RAM or so. Drop it, talk to your network team, get a network span port or a tap put in, and just throw it out there. And you'll be surprised. If you've never had any visibility on your network before, I'm sure you will find something. I've gone into lots of small and medium-sized companies who said, there's nothing wrong, we're awesome, our security's great, like there's this one admin guy who everything's perfect. And it's really good when you put something up and you find their machine is one of the ones that's owned and is doing things. So, and then just some stuff is, you can say, hey, the median is 243 days. It shouldn't be average for median. They're on the network before being detected. So, the network team and taps. They're afraid of taps a lot of times. So, they for some reason, especially if you're talking dumb taps. So a dumb tap is basically a network cable. That's what I was explaining to them. So if you're using a dumb tap, now if you're using something with smarts in it, that can do aggregation, all that kind of stuff, you got a little bit different story because those are the only taps that I've seen have problems where you get connected. But a normal tap, especially a fiber tap. So a fiber tap is just mirrors, right? So the only way when you plug it in and it works, it's always going to work unless somebody drops it on the ground and breaks something or realigns them. So there's no way that a fiber tap is going to have a problem. I mean, I'm sure there could be a problem, but I've never seen one fail. Copper taps, they are wired so that even without power, so when we would install these taps, what we would do is we would install them with power off. So it had two, we used Netgear taps and they had two connections into the back. And we would plug them in with them off so that, hey, look, see, everything works. They don't send anything out the monitoring ports, but they work. The traffic goes back and forth, so you plug this in. And the reason I'm talking so much about taps is there are issues with spans. So spans, there's a couple different things that I can tweet about some of the articles that you don't get everything from a span port. You get most things. So if all you have is a span port, go with the span port, right? Or if you need it quickly, while you're ordering taps or going through your procurement process or anything, a span will work. But there are limitations to a span. So if you have, let's say you have a big backbone switch. Let's say it's like a 6509 Cisco switch. I think there's like a 12 million packet per second limit on a switch. So if you say take a VLAN, and I don't even think there's an easy way to tell that this VLAN is pumping, let's say 5 million packets per second, and you mirror that thing, now you have 10 million packets per second, right? Because you take every single packet that switch sees, which it's not designed really to do, and you're duplicating it out that port. The other bad thing about span ports is network teams like to take them. Well, we're having a problem with the Exchange servers. We need to run the sniffer on there, right? Well, then they forget to take it and give it back to you, right? So all of a sudden, 2 days later, you're like, man, I haven't seen any alerts from this sensor in a while. What's going on here? Or seen any data, and then you figure out, oh, we're not seeing any traffic on this span.
What about the special purpose switches? They call matrix switches. Things like Gigacom.
Yeah, we'll get to that in a second. So, because they're designed for that. But like your standard Cisco switch is not. We've melted down some good sized switches doing this. So, and labeling interfaces that have a tap, it always helps. So, I have a tap right here to give away. It's a dual comm tap. It's a really, really nice one. So I have some trivia questions, or a trivia question. This is Star Wars, so all my questions are going to be movie-based, so get your IMDb's ready. How did Han Solo meet Chewbacca?
Chewbacca was a slave he freed from the Imperials.
You got it. There you go. I thought nobody was going to get that one.
I read that one.
So, I talked about placement before, so why is placement important? Well, placement means everything, right? So, what I like to do is I like to get the true source and the true destination. Why is that important? I want to know whose machine's owned, and I want to know where they were going. Sometimes when you have proxies involved in something like that, you can use X404. There are ways to yank that out of there. But typically what I like to do, so let's say your proxies on your DMZ, I like to put a tap on both sides. So I see that. Yeah, it's a little bit of extra stuff in there. They're different sessions from a session perspective, right? Because your client's going to your proxy, and your proxy's turning around and going out and doing something. So you're not going to have too much stepping on each other, and it'll be easy to weave those two together so that you can quickly put those things together. So that's very important. You also want to check the inside of your third-party router. Does anybody know why you want to go like on your VPN, why you want to go on the inside?
So the true internal IP address.
Not only that, but there's another reason why if you're doing VPN that you want to be on the inside. There you go, encryption. Right. So it's no use putting it on the outside. So this, even though your VPN traffic is coming through this tab, it's not really doing any good here because you don't see anything. Oh, there's some ESP going by. That's great. You don't really know what that is. So that is another good thing. You always want to put it in front of your secret sauce networks. And that's where we talk about, we'll talk about high speed and stuff like that. And then try to avoid asynchronous routing. This is really hard on the internet side. Let's say you have two locations that are close. There's not much you can do. But let's say in this situation you had two routers and you had two taps. You would want to bring this into the same box so that you could bring those sessions together. Because it could go out one ISP and come back the other one, and that breaks every tool. So, feel the need for speed. So, from an enterprise perspective, we're seeing lots of speed. So, I was at the Bro conference, I don't know, 3 or 4 weeks ago. I forget what it was. Anyway, we were talking to a lot of people. So, the most I've ever instrumented is 40 gig, and now a lot of these universities are getting 100 gig connections to I2 and stuff, and they're like, what do we do, right? the solution is the same for a 10 gig or 100 or 40 gig as 100 gig. The problem with 100 gig is just the interfaces cost like 40 grand each. So it's going to be really hard to monitor this. Generally, a single sensor that I normally that you can do. Generally, I can see about 2 gigs of traffic. I can maintain 2 gigs of traffic. But the big disclaimer there's lots of factors, and we'll talk about that a little bit. If you put specialized gear in, it costs a lot of money. So there's NICs that cost $15,000, $20,000 just for the network card, and I can build several systems that can do way more than with that just one system with that network card for the price of the network card. But you need something like a flow-based load balancer or a special matrix switch or whatever you want to call them. So what is flow-based load balancing? So flow-based load balancing takes multiple taps or multiple flows, takes them in and balances them across multiple outputs. So what that means is you take a 10 gig connection and now you're splitting it by 3 on a flow basis. So this isn't the perfect solution because it's not like saying, okay, this session I'm doing 2 gigs or I'm doing I've got it counts them, right? So it says it goes 1 1 1 2 2 2, right? It sends them across. But if that first connection, if somebody's downloading a bunch of stuff from they're streaming a movie from Netflix and it's going at 100 megabits versus the other person who's checking their Gmail, so it does pretty good about balancing the traffic, but it's based on flow. So you can have a single flow that can roast one of these sensors in there, but it doesn't happen very often. But it's technically possible. But it's good enough. So Bro's really good in this scenario from a clustering perspective. So if you're running a Bro cluster down here, they know about other things. So one thing, from a security perspective, if these are all running Snort, this guy doesn't know what this guy's seeing. Whereas with Bro, they all know who's seeing what, right? So you can come up with rules. Say if somebody sends out this many DNS packets within this time period, it's not just on this flow; it's for the the entire cluster group. It also lets you share with others. So we take that network team example where the network team needs to look at the Exchange servers because Exchange servers are jacked up. You can give them a feed off this load balancer. If somebody wants to test some new tool, you can give them a feed and get them off your back, right? So it's cool. Some example vendors are like Arista. Arista sells one that you need the tap ag mode. There's the cPacket CView series. There's the Gigamons. I think NetOptics has their Director series does this. There's a lot of different ways you can do it. So what does that look like though in a large enterprise? So when you have lots and lots of bandwidth. So in this scenario, we have multiple 10 gig connections to the internet, 40 gig on the back end side, and then 40 gig to our secret sauce network. What this enables us to do is to look at these links and do it from a commodity level for cheap, sort of, and do it effectively. But the downside of doing it this way is, as you can see, there's lots of these things called sensors on here. So managing all those boxes becomes a real pain. So now we've got all these sensors. What do we want? So now we have this new specialized architecture. People say, "Oh, you're putting this black box on my network. It's scary. You're going to get tons of pushback, right? Because I want to put these in there. You don't want this stuff supported by your typical support team, so you need automation, right? You do not want to be sitting around. You want to be looking for bad guys. You don't want to be adding user accounts all day and changing stuff. So I live in Kentucky. I'm not from Kentucky, but I live in Kentucky. So put a couple things in here. So hardware sizing. This is the most the biggest question I get asked all the time. I've got this much bandwidth. What kind of size box do I need? It's a hard question to answer, so I'm taking a shot at it. If somebody has better recommendations, I'm all ears. But traffic profiles, things that things of that nature, they all play into this as far as what you need. So I've had sensors that have been on seeing 2 gigs and using like 25% of the box. But it was like mostly CIFS traffic, so I didn't have a lot of snorkels. I did CIFS, and was like, whatever. But then I've had boxes on like a 300 or 400 meg connection that were getting roasted because they were like on web and they had tons of users and lots of things going on. But typically, you can use the fact that the more cores that you have, the more traffic you're going to be able to see. You need lots of RAM, so whenever you can put RAM in, that's what you need to do. So, to keep on my theme here, for a 100 meg connection, you can get away with a 4-core hyper-threaded processor, 16 gigs of RAM. I mean, you could probably go a little bit lower, but like I said, I would put 16 in there. You can use software RAID. And multiple NICs, obviously, you want to have a monitoring interface and all that kind of stuff. Now, to get up to 2 gig, it's a little bit different. So, you want to go with at least 2 6-core hyperthreads. We were talking at dinner last night. Actually, 10-core processors have come down a lot in price. So you could probably even do more than 2 gigs now with twin 10-core processors. You want to look at 128 gigs of RAM. You want to have hardware RAID file with as many disks as possible. And the reason you want lots of disks is you want more spinning trays so that you can write data fast. And you want PCI Express NICs. Quad NICs are great for this because you can bond them together. So the other question I get asked is, okay, I've got this sensors on a high-speed connection. What can I do to make this thing go faster? So these first two have to do with the way Linux handles disk cache. So in Linux, all free memory is assigned to disk cache. As it needs it, it pulls it out of there. The problem is now that you have all this RAM, you have a situation where you're not writing. So you get great write speed for 35, 45, 50 seconds, and I think the default timeout's even, 3 minutes. So you have great write speed, and then when it gets to the point that says, okay, I'm timing out now, I'm going to go write, now it's pretty horrible. So you have to pay for that speed at some point. So what you want to do is you want to balance that so that you're almost constantly writing. So you'll see a process called PD flush. And when PD flush is running, that means you're writing to disk. So you want to make sure that you can get PD flush running almost constantly. So you got to tweak these things. I think the background ratio is default 10%. So when 10% of the write cache gets filled up, it starts writing. Some kernels will only let you go down to 5%. But play with that, and then the femtoseconds, which is you can use that to determine what the best way to get that thing going. There's not really a number I can give you because this is a per sensor thing, especially when you're talking high speed. The PF ring num slots thing. Again, I have this. I think by default it's like 4096. It goes up to 65, 535, I believe. And this is just the ring size, the number of slots, or basically your safety buffer on PF ring that you can use. So that's something that's RAM dependent. So you want to be careful. So if you don't have a lot of RAM, you can't take that number as big. Same thing with the NetSniff NG ring size. This is something from a full packet capture perspective. The same kind of thing. It's just this is your buffer. It goes from the ring to this buffer, and then from that buffer to disk. So depending on you, and that helps you in the burst situation. So if you have a short burst, you're going to fill up the cache, and then you got to write that. But the more cache, obviously, the more burst you can handle. And you want to pin your processes to real cores. So if you look at if you cat proc CPU info, you'll see that you'll see a processor, and you'll see like a child processor. I forget what it's called, but you always want to put it on the real processors when you pin your processes.
What are those first two?
They have to do with the disk cache on Linux. So, like if you have 256 gigs of RAM, you have a lot of disk cache, right? So if you're going at 2 gigs per second, and you have 25 gigs of write cache, and you're writing, or it's writing cache, and then when it goes to write, then all of a sudden you're in the IO8 situation. So you want to get it to constantly write versus that big.
Would mind just swapping this play a factor?
Well, hopefully you have enough RAM that you should be swapping. So you don't ever really want to swap.
But the ratio in Linux is set really high by default.
Yes.
If you lower it down, does it play a factor?
No. So when you take disk cache, it's always seen as free. So when you do like a
Hello, I'm Geek here. Sorry about this, but we had some technical difficulties, and the section of the software that takes care of the Extreme Cap U3 seemed to have frozen up, and well, we didn't get any video of the speaker or sound here. So for the next minute or so, you're going to hear absolutely nothing. The video should start back up after that with sound, though we did lose a small section. Sorry about that.
Got to triage these. I'm seeing something about some sort of RDP session, but it's coming from VPN. We don't like to see that across VPN, right? And you can tell that by using a naming convention with your sensor, saying, you know, this is a VPN sensor. We're going to call it VPN, right? So we put VPN in there somewhere. Or, you know, this is our internal sensors. We want internal or an external sensor for traffic going outbound. You want to, you know, because if you have a system where you're using the flow-based load balancer, you can get a copy of the traffic, and it's a great place to test. Testing on real time. The hardest thing to do, one of the hardest things to do is test. Because you need real traffic, because I can put a rule set on this device and on this device, and the results are completely different. So you really always want to have a test sensor on something that's like on real traffic. So if you have a flow-based load balancer, you can do a cut, you can do that. And you want to stage your rollouts. So even though you did test it on this, roll it out to a couple test sensors in each group of rule sets that you have to make sure that it's not going to bring everything down. So then if you impact something, you're only going to impact a couple sensors instead of the whole thing. When we first started doing this, somebody would have a typo in a rule. It would take 2 hours to put the rules out there. And so we go to start up on that new rule set. It's like, oh crap. There's something wrong with this, I'm not starting. Well, now it takes another 2 hours to do it again. So when we get to the salt stuff, that's why we turn to something like that to do that. So let's talk about Security Onion. I assume everybody knows about Security Onion here. This guy probably doesn't know, but
what are you talking about?
So
it smells.
Yeah, it smells really bad. Security Onion is awesome. I'm a huge fan. But we won't go too into there. But there are some challenges with it when you come to like an enterprise level deployment. So when you have a lot of sensors, and even when I help people, if they're even putting in 2 sensors, I have them set up the onion salt stuff because it's like, look, you're going to add more, and it's just easier to do it this way. Rule management. So I was helping a friend. I was trying to tune his rules. He had 15 sensors. I wrote a shell script, adding special users that could do things. So that I could restart the rules, but then it would take a bunch of time. I was like, man, this is a pain. Because by default, Security Onion just downloads it once a night, right? So there's a cron job that runs, grabs it from the pulled pork stuff, and then the cron job runs on the sensors, and it waits 5 minutes, and then it goes and grabs those from there. There's lots of tools that you might not need. And even though it's simple, there are some learning curves, right? There's a lot of knobs you can turn to make it work to your advantage. So a couple tips. Always set up your NSM partition before you do SO setup. I've done this many times where I've created a sensor, run SO setup, and I'm like, oh crap, I didn't point NSM to the partition that I have all my space on. Now I got to move it. There's file permissions. A lot of times I would just say, screw it, I'd set up the partition and rerun SO setup because I just didn't want to deal with it. So I've done that a lot of times. Create your bridge interfaces if you're going to run. So let's say you have a tap that has 2 outputs, right, for your TX and your RX. You're going to want to bond those interfaces together or bridge them. I think either will work. But you want to create that interface beforehand so that you can point all your tools to that interface. And in my previous life, we used that a lot, right? Because we have boxes that have up to 3 taps on them, and that would have 6 interfaces. Well, they were all the same type of traffic. I wanted to look at it as one. I didn't want to have, you know, a bunch of different configurations running. So it made it so I could have a configuration across all. Turn off all your stuff that you don't need, and use it every day. This is the most important one on this slide. Because of the way Squeal works, you need to be in there and categorizing events. Because if you leave it alone for a couple days or a couple weeks, then you go and load it, you're going to get that gray screen of death waiting for stuff to come out of it. So I created uninstall because I wanted to be lazy and I didn't want to do a lot of stuff that I had to do. Mostly I did go with user accounts. So every time somebody says, "Hey, I need a user account," I hate creating user accounts. So what it lets you do is manage a bunch of sensors like one, right, and make a conformity across those devices, right? You need to standardize things. So in my previous slide, we had 500 sensors. They were all the same hardware platform. They all had the same size management partitions. As time went on and drives got cheaper, they all had different size stuff, and we had ways to detect that. But in all, you could take the config. You could lose the hardware, bring in new hardware, and use the same configuration on it, and be up and running again. It makes the user management simple because nobody wants to do that. It changes the way the rule management's done. So anytime a rule changes, it sees it and makes it and restarts Snark. So what this does, if you're tuning something, you don't have to go to each sensor or run a script or anything like that. It says, you know, if I've got it set to 15 minutes, I know in 15 minutes everybody's going to be running this rule set. Or if it's a situation where I want to get it now, I can tell them, hey, do it now. I have full control, and that's the GitHub of it. There's some stuff in there. So users are now managed centrally if you're doing it this way. By default, they're granted sudo access. They're created with no passwords, so it's all key management based. You drop your user accounts into this file, and I have an example file I'll show next. And then you drop their key into that directory. And the public key, lots of people try to send you the private key. The public key. So, our users file. This is where we put our user accounts, and it's really simple. It's a Jinja format. So these are spaces. You can't use tabs or it'll error out on you. But you just put the name of the user account, person's full name, and then the group pseudo, and that's it. You drop a key in there, you save that. Next time a sensor checks in, it will say, I need to create this user account, and I need to add them to that group. So now they're on there. With the rules, what we're telling it here is what file.recurse means install is everything in this directory, sync it. So I'm saying take everything in the sensor rules directory on the master and put it in this directory up here. And then here I'm saying, okay, I want you to wait, and if you see any changes to this folder, run this. And that's it. So what it's doing is it's saying, okay, I'm going to watch the rules file directory, rule file rule changes. I run this, and says, hey, it changed. Restart Snark. So you're good to go. Before I get the Bro Intel framework, I got some pfSense stuff to give away. I'm a huge fan of pfSense. The first one is the pfSense USB file.
Those softwares, does it have malware on it?
I don't know. They just gave this to me to give away. So if you can guess what movie this quote is from, you win the key fob. They mostly come at night. Mostly. You got it right there. All right. Now this is a big one for this T-shirt and the sticker. I think it's a T-shirt. Yeah. Where does this? What movie does this quote came from? Hey Sully, you know how I said I was going to kill you last? I lied.
Commando.
There you go. I don't want to make it, all about this stuff. So, one thing I've added is the Bro Intel framework. Let me check my time here before I go into this. So the Bro Intel framework allows you to do things. In this case, it's the scene module. Snort's really bad at doing large lists of IPs to look up because it doesn't have a preprocessor. They have the new IP. I forget what it's called, reputation protocol, but it doesn't give you context. You can't say this is this. It just says, hey, I found a bad IP, right? Well, that doesn't help when you have 10,000 IPs in your list. You want to be able to attribute that to somebody that knows, is it for some Zeus site, or is this like, ABT 600 or something? So simply here what we're doing is we're using something called file block replace. And what this allows us to do is have a section in the file that no matter what happens to it, Salt will always put it that way. So you can have all your custom scripts in your local bro. It won't touch any of that. It'll just make sure everything that's in between this line and this line equals this. So that's really, it's really all it does. So it loads the scene module or scene policy, which, and then it does the Intel notice framework, and then it reads this file we call evil.intel. So what is inside evil.intel? Inside there we have, there's several different groups, and you can look on the bro documentation. There's stuff you can go to like MD5 and stuff like that. It just didn't look good on the slide if I did it. But you can do emails, you can do domain names, and everything like that. And the cool part is you can say, okay, I want to, if I see this and I know that this is some evil group, and I can point it to a URL. So an analyst, you arm them and says, okay, I saw a bad IP. What is this? Well, it's associated with this bad group. I need to go look at it, and then I click on here, and now I've got all the details about what are the TTPs of this actor, what do they do, stuff like that. So it gives you the ability to do that. So a couple tips and tricks with onion salt. So I talked about before how you could run commands on sensors. Well, that's the command run. So when we talk about naming convention and everything like that, you can use wildcards. So you can say, if I start everything with sensor, you can say every sensor upgraded packages, right? So that's that sensor command apt-get upgrade. You can tell it to check in, which is salt call state.highstate. And I'm putting together a cheat sheet of stuff, and I'll tweet it out of some of the things that you can do there. But it gives you the ability to do things from one spot. So if you want to put VWMG on all your boxes, you don't have to log into every box. Type apt-get install. You type this, and boom, everybody's got it. So that's very, very helpful when it comes to managing one. So I type it on one sensor, well, the master in this case, and now everybody's got it. So I manage that whole grid of tons of computers as one computer. And it, because it checks in, it makes sure whatever I want to be, from conformity perspective, to be that. So what are some things I got coming up with onion salt? I want to centralize ELSA. Sorry, Martin. So that you don't have contention versus your PCAP and your flow data. You might want to keep flow data for like a year versus the PCAP you want to keep as long as you can. That could be like a couple days on your sensor. Multiple rule set support, where we talk about different sensor types. Want to have that in there so that you have different directories for different types, and you can assign sensors different rule groups. And then I want to retire SO setup for sensors that onion salt does everything for you. You just fill out a file, and it makes it happen. So, any questions? Any more questions, I guess?
Hey, Mike.
Sure.
How many? I think I may have asked this question when I asked it a different one in the presentation yesterday. How many sensors can a manager manage, I guess?
Well, if you stagger them, that depends. With Salt, I don't know. So I used Puppet in my previous life, and we were obviously able to do close to 500. With Salt, I'm not sure. That's a good question. I mean, I think the most I've seen on it is like 40 or 50. Doug, I don't know. Do you know anybody that's running more than 40 or 50?
Well, I know that there are some security onion deployments that are larger than 50. And I can tell you for Salt itself, I know that it scales to very high numbers.
Right.
There are folks in the DevOps community that are using Salt up to thousands of nodes.
Right.
So I think for security onion specifically, I think you probably run into a limitation with Squeal
Yes.
D before you run into a limitation with Salt.
Yeah, because you got the tickle. So it's a 1024 limit on Squeal. So, which I think you've got 2 connections per instance of Snort running, so that there's some math involved there. And that's just the. So if you have a sensor that's running 4 instances of Snort, that's what 6 connections or 8 connections back to the main server, and So that factors in there because it's a TCL limitation. Because we tried to overcome that in my other company, and we actually ended up breaking different services out into different things because of that. So. Suricata is another option. I personally don't run Suricata, but it is an option.
Suffer from the same multiple connection issue.
Well, even if you run Suricata, if you're talking about Squeal, you still have to have the snort agent to allow the Suricata alerts to get back to Squeal. And assuming you still want to run full PCAP, then you still have to have the PCAP agent.
Right.
So it's the agent communication back to Squeal D that's consuming the sockets.
Oh, okay.
Yeah, it's a socket limitation
It's
on
not
TCL.
the instances of snort, it's the socket.
Well, with Snort, each instance runs its own Snort agent, I believe, right? So that eats up a socket in TCL. It's 1024 limit,
I get it.
and you can't recompile it. I tried tons of different things. It didn't work. It's TCL. Any other questions? All right, great. Thank you very much.
Great job, Mike. Thank you very much. So, folks, we have lunch coming up